Hello friends, this is GM Ghosh Mathematics class. Today we discuss about the types of relation. Previously we discussed already about the Cartesian products, the definition of the relation. Now we discuss about the types of relation. There are so many types of. One is the empty relation. Or you may say void relation. One. Two. Universal. Relation. 3. The trivial relation. 4. One type relation. 5. One many type relation. 6. Many one type relation. 7. Many type relation. 8. Reflexive relation. 9. Symmetric relation. 10. Transitive relation. 11. Equivalence relation. This 7 relation is from set A to set B, or in set A means A to A. But these 4 relations are only in case of in set A or from A to A. So this is only from A to A. So there is no such other type of relation. So you be careful about the 1, 2, 3, 4, 5, 6, 7 are based on from set A to set B or in set A. That means A to A. But these 4 relations, reflexive, symmetric, transitive and equivalence, is based on in a set, or that can be set from set A to set A. Next, we discuss detail one by one. Say empty relation, inverse relation, trivial relations, one relation, one many relation, many one, many type relation. Next we discuss 8, 9, 10, 11. That is reflexive relation, symmetry relation, transitive relation, and these 4 relations are mainly for the class 12 syllabus. CBSE for class 12. Okay. So here we discuss the different type of relation one by one. First one is empty relation or null relation. So what is empty relation? A relation R from set A to set B is called empty relation or void relation or null relation if no element of A is related to any element of B, or R equal to phi, that is R equal to phi, which is a subset of A cross B. So phi is a subset of A cross B. So one of the example. Now you consider a set A, the set of all students of a boys' school, so that the relation R in A given by R, where AB order pair A is a sister of B, is an empty relation. Then here you show R is an empty relation where AB order pair A is sister of B. Next we discuss universal relation. A relation R from a set A to a set B is called universal relation or total relation if each and every element of A is related to every element of B, or R equal to A cross B. So this is called the universal relation if R equal to A cross B. Next you see one of the example, that is, let A be the set of all students of a boys' school, so that the relation R in A given by address equal to AB order pair such that the difference between the height of A and B is less than 3 meters is a universal relation. So here we discuss about the difference of the height of two students of the school such that the difference is less than 3 meters. So it is not possible for any difference of between two students is more than 3 meters in any cases. Next we discuss about the trivial relation. What is the meaning of trivial? The meaning of trivial is no value. Generally, who is more related with you and helping in all aspects, you have not given any value. Or someone who has no relation, or you have no any type of relation, you are not giving any value. So these two are most related and no related things are generally called the trivial relation. Now you see here the trivial relation. The both empty relation and universal relations are sometimes called trivial relation. So both empty relation and universal relations are called the trivial relation. Next we discuss about the number of relation from set A to set B. So very simple. The relation is a subset of A cross B. So number of subset of A cross B is the number of relation. So number of subset of A cross B is 2 to the power A cross B modulus. So same number is the number of relation from A to B. So that equal to 2 to the power A mod B mod. If A has m number of elements and B has the n number of elements, then 2 to the mn is the number of relation from set A to set B. Now we discuss about the number of non-trivial relation. So in previous section you know that there is only two trivial relation. One is the empty relation, another is universal relation. So we exclude these two relation, the empty relation and trivial relation. So number of non-trivial relation from A to B is 2 to the power A cross B mod minus 2, or 2 to the A mod cross B mod minus 2, or 2 to the mn minus 2. So number of relation minus trivial relation, that equal to the number of non-trivial relation. Next we discuss about the one type of relation. A relation from set A to a set B is called one type relation if one element of A is related to only one element of B, and there is no other type of relation, is called the one type relation. So this is set A, this is another set, set B. So there are only this element is related with this element, this related with this, this related with this. So this is called the one type relation. Next we discuss about the one many relation or one many type relation. So a relation R from set A to a set B is called one many type relation if there exists at least one relation such that one element of A is related to at least two elements of B, and there may be one type relation, but not other type of relation, and this type of relation is called the one many relation. You see, this is set A, this is set B. Now you take one element from this, and this one is related with two or more elements. So this is called there may be the one type, but there is one is related with three elements. This is one, this is two, this is three elements that is related with three. So this is one many type of relation. Next we discuss many one type of relation. So a relation R from a set A to a set B is called many one type of relation if there exists at least one relation such that at least two elements of B set is related to one element of B. There may be one type relation, but no other types of relation. You see, this is A set, this is B set. Now that will be many one. So you think here, this is related with this related with this related with this. So these three elements, so this relation, this element, this element, this element, these three elements is related with only one element. That is called the many one. So this is many, this is 1 to 3, and that related with only one. So this is many one. Or there may be one type. Then no problem. Next we discuss the many type relation. Many type relation. So you see, So this is many type relation. A relation R from set A to set B is called many type relation. If it has both many one type or one many type relation, then it is called the many type relation. You see, this is set A, this is set B. Now you see here, so this is one element, this is two elements related with one element. So this is many one type. Now you see again, so this is only one element is related with two elements. So this type of relation is called the many relation. Relation in same set. So we previously discussed about the relation from a set to another set. Here both set are same set. So you see here, this is also set A and this is also set A. This is set A and this one also set A. So the relation from this to this is R. This one is R relation. So this type of relation is called the relation from set A to set A or relation R in set A. The relation set. So a relation R from non-empty set to itself is called a relation R in set A. Next we discuss the reflexive relation. A relation R in same set A is called reflexive if A related with A for each and every element of A, that is, or A related to A for all A. So the relation for each element, you take any element of the set A and that element is related with that set, because this is the A, this is A. So each element are related with itself only. If there is A, then that is also A. If this is B, then this is also B. This is C, then this is. So for all element is related with itself. Then this relation is called the reflexive relation. Next we discuss the symmetric relation. A relation R in set A. A relation R in set A is called symmetric if AB is related here, or AB order pair belongs to R, implies B order pair belongs to R. For all AB belongs to R. The number of order pair present in set R, it has its reverse also. Then this type of relation is called the symmetry relation. That is, A is related with B, if and only B is related with A, then this type of relation is called the symmetry relation. A transitive relation. A relation R in set A is called transitive if AB order pair belongs to R, BC order pair belongs to R, implies SC belongs to R. So you see here, AB order pair and BC order, the second element of this order pair and first element of the second order pair, if equal, then you have to show AC order pair belongs to R, where ABC belongs to R. Otherwise, this can be written in another term: A related with B, B related with C, then A related with C. So first element related with second and second element related with C, then you have to show first element is related with second. If these two types of relation is not present, the first element related with B and second element related with C, then there is no need to show this one to show transitive. So it is automatically, in that case, that is transitive. If this situation is present here, then you have to show this. If this is okay, then you say the relation is transitive. The equivalence relation. The equivalence relation, a relation R in same set is said to be an equivalence relation if the relation R is reflexive, symmetric and transitive. If the relation satisfies all these three properties, then we say the relation is equivalence relation. Now you consider example 3 of your NCERT book. Say, let T be the set of the all triangles in a plane. If you draw the any type of triangles in the plane, that is a set T. Now you take R is a relation in the triangle T, given that T1 is congruent to T2. Then T and T2 are related. What is the meaning of congruence? The all sides and all angles are equal in two triangles. Means that triangles are same in all respect. Then you have to show R is a equivalence relation. So this is very simple. This is very simple. You see here, that is T1 is related with triangle T1. So you take the any triangle, then it is must be congruent to the same triangle. So it is reflexive. Clearly it is reflexive. Then second one you have to show the transitive. The second one you have to show the transitive. So how do you show the transitive? That is T1 triangle is congruent to the triangle T2. Means T1 is congruent to T2. It is conversely the T2 also congruent to T1. The T2 is congruent to T1. So T1 is related with T2 and T2 is related with T1. So it is symmetric. Next, third one is transitive. So this is also very simple. That is T1 is congruent to T2. Again, T2 is congruent to T3. Then it is clearly so that is T1 is congruent to T1 is congruent to the T1 is congruent to T3. So clear that it is transitive. So these properties, the congruence properties satisfied, the reflexive, the transitive, the symmetric and the transitive. So this is equivalence relation. Equivalence relation. Next, example 4. So what is the example 4? You see, let L be the set of all lines in the plane and R is a relation. And it is defined, R is a relation in L. L means the all lines. Define R is L1 and L2 order pair if L1 is perpendicular to L2. That means this is line L1, this is line L2. This is line L1 and this is line L2. Then clearly L1 is perpendicular to L2. So L1 is related with L2. This is. Then you saw that R is symmetric but neither reflexive nor transitive. You see here, say take the L1. You see here the L1 line is never be perpendicular to itself. So it is not. L1 is never, L1 lines is never perpendicular to L1. So L1 is not related with L1. So it is not reflexive. It is not reflexive. Next you see the symmetric. So this is the L1 line and this is L2 line. This is L1 lines, this is L2 lines. Clearly L1 is perpendicular to L2. And conversely L2 is perpendicular to L1. Conversely L2 is perpendicular to L1. That is L2 is perpendicular to L1. So it is symmetric. Now you see about the transitivity. So this is line L1, this is line L2, and this is line L3. So here you see this is L1, this is L2, this is L3. So L1 is perpendicular to L2, L2 is perpendicular to L3. But here you see the L1 lines and L3 lines, they are parallel. They are not perpendicular. So it is not transitive. Equivalent classes or partition of a set. Equivalent classes or partition of a set. An important properties of an equivalence relation is that it divides a set into pairwise disjoint subsets. These subsets are called equivalent classes, whose collection is called a partition of the set. Equivalence classes is denoted by the square bracket A containing A. For an equivalence class of relation R in set A is a subset of X containing all elements of B related to A. The equivalence classes A containing the A of A, which has equivalence relation in set R, subset of X containing all elements of B to A. Or you may write like this. So you see here, that is, if A related with B, then A contains, what contains? That contains B. If A related with C, that contains C. If A related with D, that contains D. If A related with E, that related with E, like this. So this is the equivalence class of A. Now you take one of the example, that is of divisibility of 6. So 0 equivalence classes of divisibility 6, 1 equivalent classes of divisibility 6, 2 equivalent classes of divisibility 6, 3 equivalent classes of divisibility 6, 4 equivalent classes of 6, 5 equivalent classes of 6 are the equivalent classes of modulo 6, or you may say the divisibility of 6. That means when a number is divided by 6, the remainder is the numbers which set gives the remainder is 0, it is 0 equal. The numbers which give the remainder of 1, that set is called the 1 equivalent classes. The numbers which are divided by 6 and give the remainder 2, and this number is called the equivalent classes of 2. Likewise, the remainder 3 is the 3 equivalent classes, 4 remainder is the 4 equivalent classes, 5 remainder is the 5 equivalent classes. So now you see the 0 equivalent classes is contain all these number. When you divide this number by the 6, then 0 will be the remainder. Again you see, when you divide this number by 6, the remainder will be 1. When you divide this number by 6, the remainder will be 2. So this is equivalent classes of 2. When you divide this number by 3, then when this number is divided by 6, the remainder will be 3. So this is equivalent classes of 3. Again likewise, you see here, these are divided by 6, then remainder will be 4. So this is equivalent classes 4. When you divide these numbers by 6, then remainder will be 5. So this is equivalent classes of 5. Now you take the 0 equivalent classes, 1 equivalent classes, 2 equivalence classes, 3 equivalent classes, 4 equivalent classes, 5 equivalent classes, and take the union of these. Then that will give the complete Z, or you may say the I set, the set of integers. And all these equivalent classes are disjoint pairwise. The 1 equivalent classes is disjoint with 0. No element is common here. You see, no element is common here. Here also no commons. Now you take the this and this, there is no common. You take this and this, there is no common. Likewise you take this and this, no common. This and this, no common. This and this, no common. So these are pairwise disjoints, and union is your integer set I, or you may say. So the union, so here notice that the union of all the equivalence classes give the whole set Z, or you may say I. Thank you. So kindly like this video and subscribe the channel. Thank you.